Getting into space is difficult for a variety of reasons, one of which is that breaking free of Earth's gravity requires a significant amount of energy. The only reliable way we've found to do it so far is with rockets, but a firm called SpinLaunch has a different idea. Using a giant vacuum chamber and a rotating hypersonic tether, the firm hopes to essentially throw satellites into orbit. Moreover, the startup has just completed its first kinetic test launch by heaving a vehicle high into the atmosphere. Let's take a closer look at this insane concept. SpinLaunch was founded in 2014 by Jonathan Yanni in Sunnyvale, California, and the company's current headquarters is in Long Beach, California. The key to SpinLaunch's vision of the future is the Orbital Accelerator, a massive centrifuge that can accelerate a small vehicle to thousands of kilometers per hour. The company reaches these incredible speeds by running the centrifuge inside a 91 meters diameter vacuum chamber to reduce drag. When the hypersonic tether reaches the appropriate speed, it detaches from the vehicle in less than a millisecond and sends the payload up through a chimney-like tube atop the accelerator. The rocket then ignites its engines and moves forward to place the satellite into the desired orbit. The company claims that the centrifuge can spin the vehicle and hurl it to space at up to 8,000 kilometers per hour, and if everything goes according to plan, the device will be able to launch around 200 kilograms into space, with almost all of the energy coming from electric sources. The only problem is that the orbital accelerator does not yet exist and is still under design work. SpinLaunch began with a lesser version, but it is still quite large. It took the team 8 months, a few vacuum pumps on eBay, and $500,000 worth of steel to build the world's 6th largest vacuum chamber. While 12 meters across, this first centrifuge model was still too small to slingshot a rocket into space. But the prototype established some of the mechanisms the final centrifuge would need to work. A long arm called a tether connects a bearing to a motor while the payload attaches to the end of the tether. To keep everything in one piece, despite the strain of being tossed in circles at a more than dizzying pace, the tether is built from materials with strong structural integrity, like Kevlar and carbon fiber. According to SpinLaunch, most of the launch work is done by the centrifuge, therefore, rockets don't have to be built with extreme efficiency in mind under this framework. Today's rockets can only handle payloads that take up a relatively small fraction of their overall mass, as most of that weight has to be designated for rocket fuel. The 7.6 meters long SpinLaunch rocket, by comparison, will be stocky and able to hold payloads up to 90 kilograms. SpinLaunch has been working on other elements of the system besides the giant accelerator, such as the rocket engines that will serve as upper stages to place payloads weighing up to 200 kilograms into orbit. Those engines will be conventional bipropellant designs but be incredibly low-tech versions with pressure-fed systems and few parts intended to be built cheaply and in large quantities. The company has also been testing how spacecraft components can survive the high-G launch environment. One potential issue is that to throw a few hundred kilograms into space, the hypersonic tether needs to move extremely fast. The payload will therefore be subjected to extreme centrifugal force. But SpinLaunch says it will be easy to optimize payloads for kinetic launch. As the rocket spins in the centrifuge, a port will open for a fraction of a second to let the rocket shoot out. A counterbalance that spins in the opposite direction will also be released to prevent the tether from becoming unbalanced. After coasting for about a minute, the rocket will ignite its engines at approximately 61 kilometers in altitude. At that point, little atmospheric pressure will be left to challenge the rocket's ascent, so the rocket should only require about a minute's worth of fuel to reach orbital speeds of about 28,000 kilometers per hour. Despite all of the number crunching, physics considerations, and months-long construction projects to build gigantic spinning chambers of doom, one nagging concern of whether the concept will work in real-life scenarios remains. But SpinLaunch had already succeeded in flinging a test vehicle up and out of the vacuum chamber into the air. The suborbital flight test took place on October 22 at Spaceport America in New Mexico, where the company built 33 meters diameter and 50 meters tall prototype version of its accelerator. The prototype accelerator is 1/3 scale of the operational system that is being designed. For comparison, the suborbital accelerator is taller than the Statue of Liberty by 4.4 meters. That accelerator spun up a projectile 3 meters long, releasing it at high speeds into the skies, which is many thousands of kilometers an hour. According to SpinLaunch, by starting small, they will be able to validate aerodynamic models and then scale up. The first kinetic launch only used about 20% of the system's total power, and the company is planning a series of 30 suborbital tests over the next 6 months. While the first test flight vehicle did not have a rocket engine on board, SpinLaunch plans to add that and other internal systems in later suborbital test flights. The company also plans to recover and reuse its vehicles, and the first test rocket proved absolutely flyable after engineers retrieved it. Moreover, the first customer launches are planned for late 2024. Even though the concept sounds ludicrous, the stakeholders like the US government have taken a liking to it. In June 2019, SpinLaunch signed a responsive launch prototype contract with the Department of Defense to build out its kinetic energy-based launch system to provide a lower-cost option for the ever-growing satellite industry. The company has also received more than $110 million in venture capital for its system from companies like Airbus Ventures, Kleiner Perkins, and GV. If all goes to plan, SpinLaunch says it can reduce the cost of sending satellites into orbit by a factor of nearly 20. And to boot, the company believes it will eventually be able to launch up to 5 rockets per day, which companies like SpaceX can't even do in a month yet. So, what do you think about this impressive space launch technology? Let us know in the comments below. Also, do not forget to subscribe to the channel to receive more space tech related content. And as always, thanks for watching.